All right, so first and foremost here, take a look at the review stuff on Canvas. Some of this is repeated in your notebook, okay? You should have already done the practice quiz 3.1, 3.3 prior to that first quiz. I was surprised when some people were like, there's a practice quiz for the magic chart. Oh, look at that. It's right there. I didn't even look at what I had up there. I copied everything Napier had last year, so sometimes if it's not in the notebook, I'm like, oh, hey, what's that? So if you didn't do that and you need more practice on that quiz that we just did, there it is right here with the key. All right. Then there is some Chapter 3 free response practice. Here's the Unit 3 review page on Canvas. The only thing I would be cautious with on this free response practice, I think this is the same as what is in your notebook, but let me just double check here.
The 2014 one is in the 2015.
Okay. There it is. I did not know that myself until someone pointed it out. So moral of the story is, if you're ever curious if there's more material to practice, check out the review page. There usually is. On this free response practice, these are released free responses that will contain stuff from this unit. So it's good to look at these free responses, right? This one is in your notebook. This is the right one. Yes. Yep. But there's a couple changes to this one in your notebook. So if you're going to do it digitally, go ahead and just change what they have said to change, what she has marked in here to change that's in your notebook. I'm totally fine with you doing this on your iPads. But like this, she changes in the notebook to g prime of x equals f of x. And crosses out part C. Part D is gone. So it's really just doing parts A and B. And she marked this too. So if you're going to do this on your iPad, just follow the markings in your notebook to make sure you don't get yourself hung up. Because there's things that we're going to lead into integration where we then know the original and you can come back to this stuff. The free responses on the actual AP test will contain stuff from different units. And that doesn't always work out for us when we're trying to help you practice that. So there's changes that you need there. But note that these are in your notebook as well, most of them. Let's see, other ones that are in here, they're not necessarily in the same order. So let's see where we're at here. This, ooh, that scrolled really quick. This one. Where is this one? Yep, this one's here with no changes, except for eliminating part D. Part D is not there. This one is there with a couple changes. And that one is there with a couple changes, crossing out part B. This one's there with a couple changes. Okay. It looks like the only one, there's an extra one in your notebook that is not in here. So there's another one. The first one in your notebook on page 78 is not located in this one because it's 2017. So that's also in your notebook. For answers on those, I don't know. I don't think these are containing answers here, but let me look. Okay, so she just linked the scoring standards and her work with answers. So there is answers to that. So use those as we go through those. There is Chapter 3 multiple choice practice. Always multiple choice practice is good for us to look at with our answers there as well. Make sure you're checking those. I don't believe these are in our notebook. So this is different. It says BC calculus, but whatever. Look, this goes all the way back to 1969. Isn't that crazy?
Man, they were doing AP Calc in 19.
Yes. Huh?
Dang.
Yeah. Take the quiz assignment. So there's a bunch of multiple choice practice for you. It says calculator, no calculator where needed. Oops, I didn't mean to go the whole way back out of that. Where is my mouse here? Yeah, lovely. It's not working for me. What else is there? There is a calculator practice page. Where is that up here? Yeah, so there's more free response, more Chapter 3. What is this, 2012? So yeah, there's a lot of stuff here. What I have noticed is just if there is stuff in your notebook, that has always had a big bearing on the test. The things that actually get printed in the notebook. I mean, I haven't actually looked at your test, so I'm not saying that like, go do that. But I've just noticed that historically, if she has chosen to print something because she printed these notebooks and she writes the test, because not me, it's usually pretty similar to stuff that she has like printed in your notebook. So on your notebook as well, there's a chapter 3 review with calculator. Where is that answer? Is that up here? It's the bottom one. There it is. So that's not digitally there, but this chapter 3 calculator answers down here is there for that page 77 in your notebook. I wonder if, no, there's not even more practice with that. So there's lots of free response practice. Is there anything we want to start? I mean, we have 27 minutes here, so we might as well look at stuff. I'm going to leave multiple choice for you. Sound decent? Okay. Where do we want to start? Yeah. Let's talk quickly about what could come back, additional stuff to this topic. Like I just pulled this more free response practice. What do you see here? Yeah, dy dx implicit. That could very easily come back because you can use that with the second derivative test pretty easily. You can prove that, and that's exactly what this is doing here. That's a show that dy dx question. Show that there is a point where the tangent line is horizontal, aka the derivative equals 0, also known as a critical number. Part C, find the value of the second derivative. Then tell us, is it a local max, a local min, or neither at the point? I like that question. Like if I was writing the test, that pulls back in implicit differentiation with second derivative test. That seems like a great free response question. You want to do that one?
Or no, I guess.
That one I feel like you guys can do, but I'm just pointing it out there. This one is similar to one we had in the homework.
This is like quiz questions.
Yeah, this is very similar to a homework question that we had. It's like a system where we said if it's a local min and a point of inflection. Look at that. That's a second derivative. So you can set up a system of equations by taking your first derivative and second derivative and finding your values of a and b. I also tend to take note. She's written this question. That's not a released one. So if she's written that,
it's most likely a test question.
To me, that's something she had gone above and beyond to do last year to give them an extra question to practice, which usually means she's saving something back. So I'm just going to say that seems like a good question too. All the free responses are generally good. This is just the answers then. So there's 2. Either of those 2 you feel like you wouldn't know how to go?
That would probably be asking questions about just because.
Yeah. Well, let's look at this one then. I feel like you guys could do the dy dx one. We'll look at this one then. Okay? All right, so we want to find A and B. Are we all okay with where this is? This was the more free response. Where is this? Let's look. Yeah, more free response practice. Yeah, that's where I'm at. More. Yep, page 2.
Let's see if it actually moves to notability this time.
Who knows? I could do that, but I'm recording, so I'm not going to. So, on this one, we have our f of x defined with 4x cubed, ax squared, bx plus 5. Then it tells us f has a local minimum at -1. What does that tell me? It's a critical number. What that means in terms of derivatives is that my first derivative at that point equals what?
Wait, what did you say about the local? 0.
Local minimum means my first derivative equals 0. And I will often make myself notes like that. F prime of x at, it's going to actually be f prime of -1 is equal to 0. Then it also tells me f has a point of inflection at -2. What does that tell me? Second derivative at -2 equals 0.
Wait, why?
Second derivative at -2 equals 0 because it's a point of inflection. Yeah?
Oh, and that means, okay.
So then that gives me a place to start, right? I know how to find the first derivative, don't I?
Yes.
All right, so let's take a minute and do that. First derivative, f prime of x is equal to 12x squared plus 2ax plus b. What do I then do with this? Two things. It's going to equal 0, and I also know what the x value is. What's the x value? -1.
So would you say f prime is -1?
So then I would say f prime at -1 is equal to 12 minus 2a plus b, and this will equal 0. We all okay with that fact?
Yeah.
Then I'm going to do the exact same thing, but with the second derivative. Second derivative is going to be 24x plus 2a. We then know from our given information the second derivative at -2 is equal to 0. So that's -48 plus 2a is equal to 0. If I still had an a and a b, I would do like elimination, substitution, but what do I really have here?
Oh, you can solve for
I can solve for a with this. B's gone now, right? So if I do this, this is going to say 2a is equal to 48. Therefore, a is equal to 24. If I know what a is, where can I go back and solve for b? In this one. So I have 12 minus 48 plus b is equal to 0. This gives me -36 plus b is equal to 0. Therefore, b is 36.
Oh, so, yeah, I get it.
Wait, what's 24?
A is 24. B is 36.
Okay, so 12 minutes.
All right, now, look at part B. Find all intervals where f of x is increasing. Justify your answer. How do I know where f of x is increasing?
Where the first derivative is positive.
Uh-huh. Now, my first derivative is no longer stuff with a's and b's in it. Why? I already solved for a and b. The whole point is so that now you have a first derivative that is nice. It is 12x squared plus 2 times a is going to be 48x plus b is 36. Do I know how to do like a number line and all of that?
So we just factor in the
Mm-hmm. What can I take out of this first? 12. Pull your 12 out. Gives me x squared plus 4x plus 3. This continues to factor. Okay, so now if I want to know increasing, decreasing, I immediately make a number line.
And your 2 points would just be -3 and
-3 and -1. And this is going to sound like a stupid caution to you guys. I've had a number of people put their critical numbers in the wrong order on the number line. It completely screws up your pluses and minuses. Because if they're not... yes, somewhere you need to say that this derivative equals 0, which I did not do. 0 or undefined. But yes, you need to... It can't be undefined, right. So you can just say 0. They would assume you checked undefined, right? And then because this is a quadratic, I know my plus and minus signs, right?
Yep.
So it's plus, minus, plus. So we would say we are increasing.
Oh, because it's a...
Quadratic with both ends up. Positive. So we'll say f of x is increasing. -infinity to 3 and... -3. Yep. And -1 to infinity. Because why? X prime of x is greater. F prime of x is greater than 0. Okay. That system thing has come up an awful lot in like online quizzes and stuff.
Oh, yeah.
So this is
I'm going to guess that that's somewhere going to come up. Like, it's like that whole find the slope over the endpoints and where the derivative equals that, and that's all been leading towards MBT, so that we had that.
Okay, so then we have
So-
an absolute maximum.
So then
That's when you put it back in the
absolute
original.
is when we plug back into the original, yes?
Yep.
So see if you can find the absolute. So now we're on the interval -2 to 1. What were
So
our
that
critical
would be one of
numbers?
your
What were our critical numbers from part B?
-3 to, so -3 doesn't even.
Remember to check, because that made a nasty side effect on your time on the quiz. Okay? You eliminate anything that you don't need.
So you're only gonna be working with 3 numbers.
So you're doing f of -1, f of -2, and f of 1. But when you look at f of x, remember, you know what a and b are, right? So f of x is 4x cubed plus, was it ax squared? So 24x squared plus bx plus, what was the last thing? I can't see it. Is it minus?
It was +5.
Plus 5? Is that correct? So then all you're doing is plugging in -1, -2, and 1 and seeing which one gives you the absolute maximum value.
A was 24.
I had a couple people in 7th period just give me the answer like as an ordered pair. You need to write a statement. F of x has an absolute max of this y value at this x value. So just make sure you have your f of x has an absolute max of whatever the y value is at your x value. That's your short sentence for that. Okay? All right. I know we're leaving in a minute, but my last statement about this, just a couple things that I noticed here while I was looking through. There on this one is an extra one, this even more free response, and the ones in your notebook. If you look, there's a lot of them that have a given graph for a free response. So like notice you don't have the equation, but given an f prime of x and some information about f prime of x. If you look in your notebook, there's like 4 of them on the free responses in here where you have these like given graphs. I might assume there'd be something like that on a free response. So just like that general idea, given this graph of f prime or given this graph of f of x with all this information, use it all to figure that out. Just that common setup came a lot. So that, make sure you know your IVT phrasing because that could come up with MVT very easily. I'm trying to see where MVT shows up in these free responses. I haven't seen it a lot. So I'm going to take a look at these and make sure I'll kind of send you guys a note or something if I find a good place where MVT shows up in the free responses, because I would have assumed it did.
I'm pretty sure it did.
I just haven't seen it.
Is it okay if I just
So.
like